Greetings to every one of you. So today we are going to discuss another very interesting concept from data structures and algorithm, that is Hamiltonian cycle using backtracking. Let me define what Hamiltonian cycle is. Hamiltonian cycle or circuit in a graph G with V vertices and E edges is a cycle that visits every vertex of the graph G exactly once and returns to the starting vertex. It is called Hamiltonian cycle. Let me explain with some examples. The first example, the graph with 4 vertices in which the starting node is, let us consider A. From A we can travel to B, from B to C, C to D, and then we can come back to A. So this is a Hamiltonian cycle. Take another example in which 5 vertices are there. Let us consider we start from A. From A we can travel to B. After visiting B, you can go to D, then C, then E. From E, you are able to come back to A. So in this case, each and every node is visited minimum at least once, and again you should come back to or returns to the starting node. So this is a Hamiltonian cycle. Similarly, take another way of getting the Hamiltonian cycle. A, then E, from E that is C, from C to D, D to B, and then A. This is another cycle, another Hamiltonian cycle present in this graph. Let us take this example in which the Hamiltonian cycle is not possible. Let us consider the starting node, the starting vertex is S. From S, you can travel to C, from C to E, from E to B, but again you need to pass through C. So which is not permitted, So the Hamiltonian cycle is not possible in this graph. The point, the vertex C, it is called as articulation point. Articulation point. So graph with the articulation point in which Hamiltonian cycle is not possible. Similarly, another example. Let us consider the starting vertex is A. From A, travel to B. From B to D. There is no connection from D. No node, no vertex is connected from D. So what will happen? You cannot proceed further. So Hamiltonian cycle is not possible in such type of graphs. So this particular vertex, the D vertex, is called a pendant vertex. So the graph with the pendant vertex in which Hamiltonian cycle is not possible. Okay. So with this example, I move on to a problem. How to find out whether the Hamiltonian cycle is available in the graph or not with the help of state space tree. Let us consider a graph with 5 nodes. Five nodes are here connected like this: A, B, this is C, and D, E. These are the 5 nodes, and these 5 nodes are connected like this. Now we find out whether this graph contain the Hamiltonian cycle or not. So for that we are taking the first starting node, that is A. A is the starting node, and from A find out what are the adjacent nodes from A. So there are two adjacent nodes. So one is B and another is E. Okay. So from B, what are the adjacent nodes? Check that. One is C and another is D. Is that okay? So now we have to, that is follow the depth first search. So that being the case, that is we have to, that is finish this the levels one up to the end, then only you have to, that is go to the next branch. Okay. So from C, what are the adjacent vertices? From C we have D and B. So B is already connected, so the possible node, it is D. So from D, what are the adjacent vertices? From D we have B, C and E. B and C both are is already present, so we have to, that is include this E. So from E, what are the adjacent vertices? One is a D and a A, so that is nothing but our starting vertex. So this shows Hamiltonian cycle present in this graph. So the sequence is A, B, C, D, E and again A. This is a Hamiltonian cycle. So now what you have to do, you have to, that is go back, you have to, that is backtrack. So backtracking procedure we are following here, the state space tree, and you have to proceed with the next side of the tree, next branch of the tree. So it is from D. So find out what are the adjacent vertices from D. From D you have one is C, then E, then B. So B is already here. So there are two vertices you can connect from here. You can explore, that is one is C and another is E. Now from proceed from C. From C you have B and another is D. So both B and D are already present in the the path, so that we cannot proceed. So no possibility of getting the Hamiltonian cycle here. So it is graph is terminated. Then backtrack. Proceed from E. So what are the adjacent vertices from E? So one is D and another is A. Both that is A and D are already present. So here also you cannot proceed further. So gets terminated. So what you have to do, that is again backtrack. So go to the root node, that is starting node, and from that you can proceed from E. So from E, the two adjacent nodes are here. So one is D and another is A. So A is already there. So from D you have the two possible adjacents, that is one is C and another is B. Okay. So from C, if you proceed from C, we have there is D and B. So you have already both D is present here. So the possibility is you can have this B, and from B you can reach the A. So it is A, E, D, C, B, A, E, then D, C, B, A. It is a solution, that is Hamiltonian cycle present here. So if you proceed from B, so the adjacent vertices are C, one is C and another is D. So D is already present here. So only possibility you can proceed from C. So C, and from C you can have that is B and D. Both B and D are already present, so you cannot proceed. You stop here. So in this case we have the two possible the Hamiltonian cycles. So one is A, B, C, D, E, A, and another is A, E, D, C, B, and A. Right? I hope you understood the concept, how actually this Hamiltonian cycle can be find out in a given graph with the help of the backtracking. Thank you.